Hello students! Today we're doing the last lesson in this chapter. You may have noticed that we did part of chapter 5 and part of chapter 8 together. And today we're going to learn a couple of new ways to find the area of a triangle. So depending on what information you know about the triangle, you can use one method or another. This is notes number 37. And what I'm going to do here real quick is derive the first formula for you. The second one I'm not actually deriving, it's much more complicated. So let's suppose we have a triangle ABC, and it can be any kind of triangle, and I want to find the area. Well, I don't want to use just A for area and A for vertex A, so you can see that I'm using kind of a script looking A for area, and your book does that as well. So you can just make that by going up and then down and then over, almost like making a star. So we know from long ago that the area of a triangle can be found by taking 1/2 times the base times the height, where the height and the base are perpendicular. So in this particular triangle, the way I have it set up, the base has length C and the height has length H. So that means we have 1/2 times C times H as the area. Well, here's my goal. I would like to find an area formula that involves the sides A, B, and C, or some of them, and the angles A, B, and C, or some of them, rather than needing to know the height. Sometimes we don't know the height. So what I'm going to do is use one of these right triangles. You see that if we think of the big triangle as split up into a right triangle on the left side and a right triangle on the right side, then we can use trigonometry with one of those right triangles. So suppose I use the right triangle on the left side. We can say that the sine of angle A is opposite H over hypotenuse B, and when we isolate H by multiplying both sides by B, we get H equals B sine of A. So what I'm going to do is I'm going to substitute that in for H in my previous formula. So now we have the area of the triangle is equal to 1/2 times C times B times the sine of A, sine of angle A. And just to make it look a little bit nicer, I'm going to rearrange the order of the letters B and C. So the area is 1/2 times B times C times the sine of angle A. What I want you to notice is that B and C are consecutive sides. Here's B, here's C, and A is the angle in between. We call that the included angle. So it doesn't matter if you have sides B and C, or if maybe you have sides A and B. If you had sides A and B, you would use angle C, the included angle. Or if you had sides A and C, you would use angle B, the included angle. So that means we have 3 different versions of this area formula. 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. Okay, just the same formula written in 3 different ways. Now let's do a couple of examples. So we're finding the area of triangle ABC, and we're given in number 1 that side A has measure 37, side B has measure 48, and angle C has measure 52 degrees. So if we were to make a sketch, of course it's not going to be to scale, but if we just sketch any old triangle ABC, across from angle A is 37, across from angle B is 48, and then angle C 52 degrees. So you see we do have the information we need to use this formula because we have a side and the included angle, the angle in between. So let's use the version that says area equals 1/2 AB sine C. By the way, this here, that's a capital C. It just doesn't look like it in that font. Okay, so let's substitute the numbers in. We have 1/2 times 37 times 48 times the sine of 52 degrees. Now notice that the directions for this problem say give the exact answer. So that means I'm not going to put sine of 52 in my calculator because that's not going to be exact, but what I can do and should do is multiply 1/2 times 37 times 48. We can simplify that much. That's 888. So our exact area is 888 sine of 52 degrees. That is exact and simplified, and I don't know the units. Maybe it's square inches or something. We weren't told. Okay, so that was a very straightforward one. We had everything we needed. We just plugged it in the formula. For number 2, what we're given is side A, angle A, and angle B. So we're not given the information we need to use the area formula. Not yet anyway. We're going to have to find it. And notice that the directions say, for this one we can give the approximate answer. And that's because we're going to end up using the law of sines or the law of cosines to find more information. What do you think? Do you think it's going to be the law of sines, or do you think it's going to be the law of cosines? You're right. Let's use the law of sines. Because what we can do is we can do A over the sine of A equals B over the sine of B. And we know 3 of those things, so we can solve for the 4th. 58 over the sine of 35 degrees equals B over the sine of 67 degrees. Let's solve that for B, and when we get that answer, we're going to store it in the calculator. So for that, I got 93.1 if I round to the nearest tenth. It doesn't really matter how we round because we're storing it anyway, so don't forget to store. Now, I have A, I have B, so what angle do I need in order to use my formula? If I have A and I have B, then I need to know angle C. And that's easy to find because we already know angles A and B. So to get angle C, let's subtract the other 2 we know from 180 degrees. So angle C is 78 degrees. All right, so now let's use the formula. Area equals 1/2 AB sine C. And we'll substitute in our values. We know A, little a, the side length is 58. We know little b, it's approximately 93.1, but we're going to use the calculator and use the stored value. And then we have angle C, 78 degrees. So let's put all of this in the calculator. Using the stored number, 1/2 times 58 times the stored answer for B times the sine of 78. And for that, I'm getting 2,640.4. Okay, that's a large number, but remember this is an area, and we used fairly large numbers to find it, like 58 and 93, so that's not really a surprise. And let me change those symbols so that it says approximately. And for units, I suppose we could just put square units on there. That way we're not just ignoring the fact that there would be units. Okay. Now, there is another formula that I want you to learn today, and it has to do with how to find the area of a triangle if you know all 3 sides. So, I'm not going to derive this formula for you. The process is a lot more complicated. I think in your book they do have the derivation, so if you're interested, you could read that. This formula is called Herons formula, named after someone named Heron. Sometimes it's known as Hero's formula. Apparently he was called that too at times. I would say he's a hero for giving us this formula, which at first glance doesn't look good, but actually compared to alternatives of what you would have to do if you didn't have the formula and you had all 3 sides, it's actually not so bad. So here's the plan. If you have a triangle with side lengths A, B, and C, the first thing you're going to do is calculate this number S. S is A plus B plus C divided by 2. In other words, take the perimeter and divide it by 2. Now I would recommend that if that doesn't turn out to be a whole number, leave it as a fraction. It's going to be a lot easier to simplify your work if you have a fraction and not a decimal. So once you have S, you're going to use this area formula, the square root of S times S minus A times S minus B times S minus C. So let's do an example. Find the exact area of the triangle using Heron's formula. And we're given A, B, and C, 3, 4, and 6. Okay, so let's start by finding S. 3 plus 4 plus 6 divided by 2. So that's 13 halves. So I'm leaving it as 13 halves. I'm not writing it as 6.5. And you'll see why. because now as we find the area, we're going for the exact answer, remember, not some decimal approximation. So we're going to have a radical answer that's simplified as much as possible. So in the formula we have the square root of s times s minus a times s minus b times s minus c. So that's going to be the square root of 13 halves times 13 halves minus 3 times 13 halves minus 4 times 13 halves minus 6. Okay, I'm going to simplify each of those expressions. So we have the square root of 13 halves times 13 halves minus 3 is the same as 13 halves minus 6 halves, and that's 7 halves. 13 halves minus 4 is the same as 13 halves minus 8 halves, and that's 5 halves. 13 halves minus 6 is 13 halves minus 12 halves, and that's 1 half. Okay, so let's multiply the numerators. First of all, if any of your numerators were perfect squares, you would want to factor them out, but 13 and 7 and 5 and 1, those are not perfect squares and they don't have any common factors. So if I multiply them together, I get 455. And when we multiply the denominators together, we get 16. That is a perfect square. And the square root of 16 is 4. So our answer is square root 455 over 4. Or if you want, you can write it as 1/4 times square root 455. Same thing. Square units. Okay, I think we have one more example to do. A heron triangle is a triangle having integer sides and area. Remember what integers are, like 5, 6, 7, not 1/2 or 2.3. Integer area as well. In the last problem, the area was not an integer, it was an irrational number. Determine if the following side lengths make a heron triangle. Well, we see the sides, 11, 13, and 20 are all integers. So what about the area? Is it an integer? That's what we're going to find out. So let's start by finding s. 11 plus 13 plus 20 over 2. And that is 44 over 2, and that's 22. Well, so far so good. That part is an integer. Now let's find the area. The square root of 22 times 22 minus 11 times 22 minus 13 times 22 minus 20. Let's simplify this. Square root of 22 times 11 times 9 times 2. And in fact, I'm going to break 22 down into 11 times 2, and then we have times 11 times 9 times 2. So look what we have. Inside the square root, we have 11 squared, we have 2 squared, and we have 9, which is 3 squared. So when you take the square root of each of those, you get 11 times 2 times 3, so you get 66. And 66 is an integer, so we can conclude that we do have a heron triangle. Okay. Now, if we were at school not learning during a pandemic, we would also be doing this kind of problem, which expands our use of triangle area formulas, and we get to use them to help us find the area of a quadrilateral or some other shape. We're not actually going to do that this year because I'm trying to keep your lessons short and reasonable. But I just want to take a moment to show you what you could do, and some of you might be interested in the challenge. So suppose we have this quadrilateral, and we know some of the information. We know some sides and some angles. If we want the area, if we have the right pieces of information, here's what we can do. We can divide this by drawing a diagonal and divide it into two triangles. I'm going to call this triangle 1 and triangle 2. Notice that for triangle 1, we have a side and the included angle. So we could use our first area formula that we learned today to find the area of triangle 1. Then look at triangle 2. We have a side, We actually could go back to triangle 1. We could use the law of cosines and we could find the diagonal length, which I'm going to call D. We could go back to triangle 1 and we could use the law of sines to find this angle right here, which I'm going to call theta. And then we could subtract from 132 to find this angle here, which I'm going to call alpha. And once we have that, we could use the side, the included angle, and the side to get the area of triangle 2. Okay, so that would be the process. And because we are using approximate answers from the law of sines and approximate answers from the law of cosines, we're going to store a bunch of things and just end up with an approximate result. Okay, so your homework assignment is to do a few problems where you're using the first area formula and a few problems where you're using the second area formula. And you're definitely welcome to try this challenge problem if you're interested in using those formulas and the law of sines and law of cosines to find the area of a quadrilateral. And if you do that, you can check your answer with me. Thanks, everybody.